I'm Mark Kavanaugh for Cavi Coaches, and today I'm going to coach you up on the 2025 AP Physics 1 exam. These are the FRQs. This one's going to be question 1. So in this series of videos, we're going to talk about the AP Physics 1 2025 FRQs. These are the solutions, and we're going to look at free response question 1. This is version J. So the question is stating that a student has a car mass that's called MC, and a block has 1/5 of that mass as shown in the figure. And at time t equals 1, the cart's moving to the right at a horizontal surface with a constant speed of vc, and the student releases the block from rest. At time t equals t1, the block collides and sticks to the top of the cart, and the block does not slide on the cart. At time t equals t2, the block and cart continue to move to the right with a constant final velocity of vf. And our first task is on the axis shown, we're going to graph the horizontal momentum of the cart block system. Now the key here is it's the cart block system. So to represent the cart block system, what we're going to do is we're going to draw a momentum bar chart. So momentum bar chart has both positive and negative, but we're saying that it's moving in the positive x direction. So what's moving before the block collides is the cart. So we're going to draw a bar on the positive side. And then we know that's a constant value, so we're going to draw a horizontal line representing the cart's momentum up until the block lands on it. Once the block lands on it, we know that the cart is going to slow down, so its momentum decreases. But because the block is part of the system, the collision, there's no external forces, so that means the block is going to increase in momentum horizontally the amount that the cart decreased, which means that our line for the horizontal component of the momentum is just going to be a straight line all the way across horizontally from the time the cart's moving till after they collide and stick together. Part 2 asks us to derive an expression for the speed, Vf, of the block cart system. After time t equals t2, we want to use mc, vc, and any physical constants as appropriate, and begin our derivation by writing a fundamental physics principle. So conservation of momentum is going to be our fundamental physics principle. So the initial momentum of the cart is going to equal the final momentum of the cart and block together. Now we can go to our reference information packet and we can substitute the equation for momentum as mass times velocity. So we have the mass of the cart times the velocity of the cart is going to equal the mass of the cart block times the final velocity. Then we can substitute the value for the mass total of the cart and block, which is going to be mc plus 1/5 mc. Then we can simplify that equation, and we get mc vc is equal to 6/5 mc times vf. Then we can see that we have mass on the same on each side, mc, so we can cancel that out, and then we can solve for vf to get an equation that vf is equal to 5/6 of vc, so that we know that the cart slowed down, and this makes sense that it have a slower velocity, but the momentum total is equal because the mass increased. Now we want to derive an expression for the change in the kinetic energy in the cart block system from the times that are given in terms of mc and vc and any physical constants. So we're going to begin by deriving an equation or using a fundamental physics principle. So our fundamental physics principle that we're going to use is that this is called a perfectly inelastic collision because we had two objects collide and stick together. Momentum is conserved in a perfectly inelastic collision, as we already proved. But what happens is the kinetic energy, some of the kinetic energy is lost. So we have a decrease in kinetic energy. So when we find the change in kinetic energy, we take the final kinetic energy minus the initial. Then kinetic energy for each of them is just 1/2 mv squared. Now we have the final mass times the final velocity squared minus 1/2 of the initial mass times the initial velocity squared. So we're going to substitute some of the values that we know. What we know is that the mass final is 6/5 mc, and we know that the initial mass is just mc. And then we can substitute in our final velocity that we derived in the previous part, And we end up with an equation of 1/2 of 6/5 mc times 5/6 vc, that quantity squared, minus 1/2 mc vc squared. Now we're going to do some simplifying of this. 6/5 times 5/6 and that quantity squared. That means one of those 5/6 cancels out with the 6/5, which leaves us with one of those 5/6. So we end up with 1/2 5/6 mc vc squared minus 1/2 mc vc squared. Then we're going to multiply by 1/2, which is going to give us 5/12 times the mass of the cart times the velocity of the cart squared. And then we're going to find a common denominator, so we'll just make 1/2 into 6/12, and we can do 5/12 minus 6/12, and that's going to give us a negative 1/12 mc vc squared. That's the amount of change in the kinetic energy, and this makes sense, as we said, it's a perfectly inelastic collision, so that means we should have a decrease in kinetic energy, and that's what we have with our negative value, a negative 1/12 mc vc squared. Now, in part B, we want to consider the case where a new block is dropped and collides, and in this case, they slide to a stop during the collision. So during that time interval, we want to know if we want to indicate whether the x component of the momentum of the new block cart system increases, decreases, or remains the same. So we're going to justify our response. We're going to draw, again, a momentum bar chart. So before the block's dropped, we know that the cart's moving. After the block is dropped, we know the cart slows down. But again, this is still the block cart system, and the frictional force between the two surfaces is what's causing it to stop. In this case, it's kinetic friction. In the previous problem, it was static friction. So that's still conserved. So momentum is still conserved in this situation. So what that means is that because the friction force is between the cart and the block, both of those are in the system, this means that there is no external force acting on the system to cause a change in momentum. So we're going to check remains the same. So this is free response question 1, version J on the 2025 AP Physics 1 exam. I hope this was helpful, and I hope you have a great day and an even better tomorrow. If you found this video helpful, click the like button down below, subscribe to my channel, Cabby Coaches, and follow me on Instagram and X at Cabby Coaches.